All right, we're going to derive this formula, right? The power rule formula that we learned to use in this last section. And we're going to do it by using the limit definition. So here's the formula, right? That the derivative with respect to x of x to the n is n times x to the n minus 1. And that formula is what allows us to not have to set the limit every time we need to find a derivative. So it's super useful. So we're actually going to just, I'm going to just work out how we get this result by using the limit definition. So in this case, our function is x to the n, right? We're going to find f prime of x. So then f of x plus h is x plus h to the n. Now, when we find derivatives, right, of x to a power using the limit definition, right, we do that algebra where we expand that power, right, so we could write out all the terms. Here that's going to be a little bit of a challenge, but we're going to be able to do it well enough to see what the limit is that we need to find. So remember Pascal's triangle, right? Pascal's triangle is the one that starts with 1, 1, 1, 1, 2, 1, right? We use it to help us find like x plus h to some power, right? 1, 3, 3, 1, 1, 4, 6, 4, 1. So this is, right, row 3, right, because it starts at row 0. We call that row 0. Right, and if I wanted x plus h cubed, I use row 3 to get those coefficients. If I use, if I want x plus h to the 4th, I use row 4 to get those coefficients. So what I know about x plus h to the n is, aside from the coefficients, right, I know that my first term is going to be x to the n, and then in my subsequent terms, with some unknown coefficients here, I'm going to decrease the power on x, introduce an h, decrease the power on x, increase the power on h. And, we don't know what n is, right? N is not, defined right now, right? We haven't set a specific value for n. We just know that it's some integer. So this goes on, right? And then I know that the very last term is h to the n, okay? So now if I want these coefficients, if I go back to Pascal's triangle, I need the nth row. I need row n. And if row 3 is the one that begins row 3, and is the one that begins 1, 3, and row 4 is the row that begins 1, 4, I know that row n is the one that begins 1, n, and then there's all these other values in there, and it ends with n, 1. Okay, so there's all those other values in there which we don't exactly know, but that's not going to be a problem for us. So I know that this is 1, n, and then some of these other ones, right? Whatever, and then that's a 1 at the end. We don't know what those are. As it turns out, we're not going to need to know. So f prime of x is the limit as h approaches 0, f of x plus h minus f of x all over h. This is the limit as h approaches 0 of, so up top I've got 1 x to the n plus n x to the n minus 1 times h to the first plus some unknown coefficient x to the n minus 2 h squared plus some unknown coefficient x to the n minus 3 h cubed all the way down to our last term we know is a 1 h to the n. And then we're subtracting f of x, so we are subtracting x to the n. We can go ahead now cancel the terms, a positive x to the n, a minus x to the n. And now every term that's left in there has an h in it. And we're going to factor out the h. If I take out the h, then what we have left inside, well, this first term, if I take out the h, is n times x to the n minus 1. And then we have some unknown coefficient. If I take out an h there, I have x to the n minus 2 times h. And then I have some unknown coefficient here, x to the n minus 3 times h squared. And then some other terms, which I just know they all have factors of h in them. All the way down to h to the n minus 1, because I took out one factor of h. Now we're going to cancel the factor of h. And here's why we don't care, right? It doesn't bother us that we don't know those coefficients. Because those all, even after I factor out the h, those all still have a factor of h. We want the limit as h approaches 0 of n times x to the n minus 1 plus some unknown coefficient x n minus 2 times h x n minus 3 h squared. Right, all of these, except with the exception of the first term, these all have a factor of h. And so they zero out. They approach 0 as h approaches 0. And so when we apply the limit now, we get n times x to the n minus 1. And that is the derivative with respect to x of x to the n.